Hello, everybody. I hope you can hear me well. My name is Lander. Most of you probably know me. Let's wait a second till everybody is online. Well, I hope that you are doing okay. You're doing well. Everything is working. A confirmation would be good, maybe. So wonderful day today. Again, Christmas is coming. It's a beautiful time to be around, and we have a new present for you. I hope you enjoy it as I do. I'm excited to present you the first demonstration, the first look at the new version of COPRA FEA, and we'll go then directly to it. Let me share the screen. So in this new version, we have a couple of features I think that are interesting for you. Some other features that are quite specific, you will not be using a lot, but when you need them, you will be happy that you have them. So I don't know if you already downloaded the new version. You will have to look at the release notes, but we already prepared simulation. As usual, my nice channel. I have a simulation where I manually already also meshed this bend. So just this bend, now I have to continue simulating. So as usual, the exercise is to start to create a new model. R, for example. I go into the folder, comments, loading COPRA to FEA. And load settings, no, on 10, load settings. But in this case, meshing reference is the last one, and 16 is my end station. I check the material, process, station distances, run project. So nothing new up to this moment. Okay. The new mark mentat opens. This is the mark mentat 22.2 version. It doesn't look too different to the previous ones, but of course, it's always improved. So this shouldn't take too long, right? As usual, any questions you have at the end of the session, we have a Q&A session. The ones that want to stay can stay and send us the questions, and I'll be sitting here and chatting with you. So what I want to demonstrate now is the new feature to, not to restart, of course, but to import meshes not meshes, but to import parts, portions of the previous simulation, right? So that's the word which is important. I don't know the increment. The new one is 8 actually. Yeah. Not include. I always look like not include. And so nothing new, nothing fancy up to here. But I guess The interesting part comes when we go to modify. We're getting first snow today, maybe. I had to come with my colleague because I did not change my to winter tires yet. So, but this is very typical here in Germany. Some snow before Christmas. We don't get the white Christmas, but a green Christmas again, then because it warms up, and then in January the really winter comes. So this is done, modify, and here we see this new import mesh. Yeah. So now, of course, I don't want to do the second bending manually, but I mesh the complete mesh from COPRA to FEA from this model. So we see we have the two bends. But the problem now is that I lost the manual changes I did in the first bend. What do I do now? Huh? And that's where it comes, this advanced import. This is what's new. Because now I can go to the previous one and select the manually changed one. And this will be positioned 25 millimeters. Of course, we can change this. Yeah. But it will be on top. It will be positioned on top. So we will see two meshes right now. Right? Yeah. So two meshes. Quite magical, right? So now close it. And what I'm gonna do is delete. I find the delete one. Yeah. Elements from my actual mesh and from the top mesh and join together. So now I have to move the top one to the bottom, not the bottom one to the top, because otherwise when we start the simulation it could be a mess. So we have to be careful always, as usual. We have to think. We know all that this is no software for people that don't think with, so we have to think and say, okay, 25 millimeters minus, and what we want to move are elements. Well, it could be nodes also. So we have a thing that do not match because the nodes were not in the same position, of course. That wouldn't be too easy. So the last thing I need to do is move nodes. So from here to here, not in Z direction, just in X direction. Nodes, and always with the box here. Ta-da! Yeah, quite exciting, right? So now we click at deformed. And I'm pretty confident that this will work. Okay, look at this, beauty. We have the new bend and the manual change original bend here. Is this not great? So we update. And now we can run the simulation. Start simulation. Don't forget, we have the possibility of the queues. Yeah. And now you see here, this is a second thing I wanted to show you, the improved or enhanced area of process control CPC, where now we also have estimated remaining time area of course, this is like at your car, it changes depending on if the simulation is in a difficult station. Yes, depending on really that. Yeah, it's like on the car, with the car, you're going up the hill or down the hill. Yeah, it's the same. So it's we cannot be 100% sure that what we now see 15, 16. So you see, it's going up. It's what at the end we'll need, right? So this is one thing we have, and the other part of here new is in the simulation monitor here, we have a lot of graphs with more information. So for example, well, this is not a simulation with friction, but friction information here, we will have a lot of things that could be interesting also, of course. Yeah, how much we will need this, I don't know, but we could get sense of better sense of where the simulation is taking long, and then we check it in the simulation results, right? So we have to still investigate things, but this is the more information we have, the better, right? So we are not blind and we don't know where to look for problems. So this is something could help also. So have a look at it and let us know. You have more information in the wording of the release. Yeah? So let's go to the results file. This is all about the pre-processing, I think, and the run area. So let's go to the result area, because here we have also some exciting things. So I'll leave that running, maybe open the previous one. Did I click twice? No, it's not gonna crash. Don't worry. This is great. So, well, okay. So right now, this is quite a short strip, but you see that in the navigation tool bar, we have also the sheet overhang directly here, so you don't have to go through, I think it's a show menu, maybe, I don't know. So this is one thing also we changed, or we have it, but nice thing we have new is in plot from element. Now you see it's a little bit enhanced. Yeah. So now we always have the values of the maximum value, minimum values here of the nodes. What we don't see the nodes. So now we can see the nodes by clicking here on model. So the nodes are with the maximum and minimum values will be here. So that's a nice thing. But the other thing, which is even nicer, is that, of course, these values sometimes are in the area where we are not investigating. Yes, we talk always about the continuous forming area when we are forming with coil, of course. So we don't really investigate results in the entry and the rear part, because these are areas that have these tendencies. Yes, so we want to investigate this part. So all we could do until now was to change maybe the color settings, change manually the minimum and maximum. But now here we have a selection area. So if we click here, you see that now a portion, just a portion of the strip is taken into account to show the results. Yeah, so we can manipulate, of course, this portion by clicking here plus and minus. Yeah, and this way, for example, when we are looking at maybe strain in longitudinal direction, we don't have to change anymore the maximum values, what we were always all the time changing them in the settings of the range. Yeah. So that's in plot from element area. So we have here post elements in current station, or we can fix the elements, because when we are working with the friction model, the strip is moving, so we cannot fix it in the line. We cannot fix it in the sheet, in the line, sorry, because the strip is moving in the line. So we have to fix it in the sheet. So now, if we fix it and we move along, we see that always the same portion is visible. Yes, because if we are using in current station, of course, if we are in a between station and idle station or not, you see that it changes the area. Yeah. So we have current station or fixing it, and we can fix it in line or sheet. And then we have here also possibility to exclude the elements that we are not showing, or we are not showing with the values. Right now I have full view, but I hide them. Also, again here, this is no cutting. Yes, this is just visualization, of course, just a reminder. Or we can do translucent, which is also nice, I think. Yeah, so this way, this is also a nice feature. Right? Actually, it's not nice. I think it's a great one. I mean, this is what we've been looking for all our lives, and we didn't even know it. Yeah, right. So you see that if I have this selection, I can manually, temporarily add more elements. This is temporary, but this, so when I navigate, it goes away. Yeah. Good. So great feature here in plot from. So let's go to the advanced length cut area. This is another one. This is really. So you see that now we don't have this before and after, but we can hide the parts, the rear and the front part. This is just the best, right? We don't have these disturbing areas anymore. It took us about time to do this, yeah, but we finally done it. So you see here, before we do this, we have to click at prepare geometry data. I already did this. It doesn't take too long, because right this way we have also the possibility, or we see the sections in a we can have at the same position the uncutted, which is now it's the same as the element. Yes. So this is a section geometry. It's not the strip. Uncutted one. And of course we can compare them. So now I have the cutted part, which is the orange color, and uncutted blue. So we see what kind of movements we have, if we have end flare, twist, and this all kind of things with the visualization. Yes. And we can do that also with the rear part and the front part. So this is also a nice one. So this would be these post-processing tools to investigate end flare. And sometimes we know that when the profile is cutted, it also, because we just, it moves a little bit, it keeps a little bit, maybe because we are only holding it in one node. Of course, we want to release the forces, so it should move, but sometimes it moves completely down. So to move it back to the same level, we can change the orientation of, for example, the cutted part. Yeah. So that works just by clicking at orientation and then selecting. Let me see. Let's see the notes. Oh, yeah, here. So then I have to just select one node, second node, and third node. Did I select the third one and apply? Yeah. So you saw that I oriented the uncutted one with the cutted one, so I can compare them better. Well, in this case, this profile, there is no end flare, yeah, but this is a really nice feature, I think. Also. Good. So what else do we have? Now we don't have too much time anymore. Let's have a look. Not that so this is something also some customers have been waiting for. Now we have the possibility to export not just geometry, but results to another format like LS-DYNA, which is used lots for crash tests and so on. Yeah? So now we have the possibility in the import-export area to export results, mapped results. So you see here, LS-DYNA, we can create the export, the mapped in cell with shell elements or solid elements. Yeah, and that's all. So this is something I don't think I have to demonstrate. Export as STL. So now we are gonna get rid of edges. We think that with STL we can achieve the same and better. So there's no extra costs anymore. I think this is a compromise which will be beneficial for all. So we don't have to also have any external costs and so on. Yeah. So I think we are substituting edges by STL for 3D export of the geometry, for example. And that's also here in the import export. The cut stays the wireframe format. So we have this area and this is new. Yeah. Good. This thing. Maybe I should demonstrate diamond remeshing. This is also we're not going to use it all the time, but this could be interesting. When we have sharp radius, and we have sometimes the problem that two nodes come close to each other, they collapse. How can we avoid these kind of things? Well, we have also achieved automatically the possibility to create new mesh, what we call diamond remeshing. So we have the three from one element to 3 and 2 element transition, but now we have the diamond remeshing.
It works like this. We open the restart model. We go to modify and first would be better to see where we actually want or what the position of the sharp point will be. So where it's gonna be the the coming together, or where will be the collapsing of the radius. So imagine this is the position, yes? So I can make maybe like this. I can add a marker of the position. Okay, and make it flat again. And now, before I do this diamond remeshing, it's better to make the division of the elements to the neighbor ones also, maybe like this, because we're gonna get a diamond like the one element here, so it would be too rough if we don't if we not remesh here. So now it's really easy. The position, all the nodes in the position, of course, we have to select with a box and right click to confirm and just click at go. And now we should see the diamond look like mesh in this place. This is perfect. Good. So we go to deformed. So we are able to update model. So it's updated. And this is how it looks like after in the deformed form. We update and we're ready to start the simulation. So that's all about the diamond. It's as easy as also the transitions from 1 to 2 or 3 elements. Okay, and okay. So I guess we've been through all the functions I wanted to share. We also optimized the advanced restart to symmetric restart, and some you can read in the release notes all the other small things we also optimize. Good, thank you then for the time sharing with me. Any comments, any feedback, please let us know. We are always available. And of course, ideas, functions you would like to get developed in our software, please let us know. Because without your feedback, we are nobody. We don't know which we know, but it would be nice that also we get some ideas from you in which direction we should go. Of course, it's always what we want as fast, reliable simulations. Reliable they are already, and it will be faster and faster, but we also at the same time do finer meshes, do more complicated things. So good, guys. Q&A time, and anyway, have a nice time ahead you, and talk to you soon. Bye.